Alright, AP Stats students, I'm going to try to do 6.2. I did the whole video and it didn't record, so I'm going to try this again. Hopefully it actually works. Transforming and combining random variables. So we talked about transforming before a while ago. Hopefully you should be solid on that. So let's remember some of that stuff first. When we add and subtract by a, which is a constant, to every data point, the measures of center and location, mean, median, quartiles, percentiles, z-scores will all add or subtract by a. The shape and the spread of the distribution will not change. So that's the same. Remember, the whole distribution moves up, so the width doesn't change and the shape doesn't change. When we multiply or divide every data point by b, which is a different constant, the measures of center and location, mean, median, quartiles, percentiles, z-scores, will multiply or divide by b. The spread of the distribution will also multiply or divide by b. And the shape of the distribution will not change. Right, wider and narrower does not change the shape. It's still either symmetric or skewed. So the same rules apply to random variables. So we'll start with a simple example of a discrete random variable. Pete's Jeep Tours offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. The number of passengers x on a randomly selected day has the following probability distribution. So you could see that we have 2 passengers, there's a 15% chance of that. There's a 25% chance there's 3, 35, then 20, and then there's a 5% chance there's 6 passengers filling up the Jeep. What is the mean of x? Well, we could do this two ways. We could say 2 times 0.5 plus 3 times 0.25. I'm not going to do that. I'm just going to fill it in my calculator because I've already done it once. So there's our Jeep tour data. We do our one variable statistics and we get a mean of 3.75 and a standard deviation of 1.08972. So we're using the population standard deviation, which is rare because we have all of the data. This is population. We don't have a sample. So mu of x, or we could say the expected value of x, equals 3.75. And the standard deviation, we're using our sigma of x for population, 1.09. Pete charges $150 per passenger. Let's see the total amount of money that Pete collects on a randomly selected trip. Because the amount of money Pete collects from the trip is just 150 times the number of passengers, we can write C equals 150x. From the probability distribution of x, we can see that the chance of having 2 people, x equals 2, on the trip is 0.15. In that case, C equals 150 times 2, which is 300. So one possible value of C is 300. So 300 equals 0.15. And its corresponding probability is 0.15. There you go. If x equals 3, then C equals 150 times 3. So that's the profit that he makes. And the probability of that is 0.25, right? These all were just, this is the 2 people in the Jeep, 3, 4, 5, and 6. That's how much profit and the likelihood that he would make that profit. I'm not going to sketch the new histogram because it's going to be exactly the same, a different x-axis. The mean, remember, mean of C, well, the mean and the standard deviation both just multiply by a constant. 150 times 3.75, 562.5. And the standard deviation will also multiply by that constant. So 150 times that 1.09 equals 163.5. It costs Pete $100 to buy permits, gas, and a ferry pass for each half-day trip. The amount of profit V that Pete makes from the trip is the total amount of money C that he collects from passengers minus that $100. That is V equals C, which what we had from here, minus 100. If Pete has only 2 passengers on the trip, X equals 2, then the collection he makes is $300, and V equals 200 because it's 300 minus that 100, so $200 is his profit. From the probability distribution of C, the chance that this happens is 0.15. So the smallest possible value of B is 200, and its corresponding probability is 1.5. If X equals 3, then he collects $450, but pays that 100 and profits $350. The corresponding probability is 0.25, and you keep going, and you can have that whole table. So this new histogram will also be exactly the same with that different x-axis again. So remember, measures of location, like mean, because that's a location in the middle, those we would subtract the constant. So it was 562.5, so equals 462.5. The standard deviation does not change because the constant will not affect that standard deviation. So this is still 163.5. So when I add and subtract a constant, location measures change. When I multiply or divide by a constant, both measures change. Now we're going to combine random variables. So what happens when we are not adding a constant to a data set, but rather another data set? So one data set plus another. For any 2 random variables x and y, if t equals x plus y, so this is one variable plus a different variable, so we're putting 2 variable sets together, then the expected value of t is, well, you add them. Mu of t, expected value of t. Remember, expected value is the same as average. You just add them or subtract them, whatever you're doing. In general, the mean of the sum of several random variables is the sum of their means. For any 2 independent random variables, x and y, if t equals x plus or minus y, then the variance of t is sigma squared of t, right? That's a variance. Sigma would be the standard deviation. Sigma squared is the variance. It's been a while since we've done that, but we did talk about that at the beginning of the year. All you do is add them. No matter what, add or subtract, you're adding the variance. If you think about it, the spread of the distribution is always going to get wider. If you put one distribution with another, there's going to be more variability. If you subtract one distribution from another, you're still putting 2 together, so the variability is increasing. In general, the variance of the sum of several independent random variables is the sum of their variances. So if you have 3, 4, 5, you still add variances. Variances add, standard deviations don't. So keep that in mind as we do this example. So suppose you earn $12 per hour tutoring elementary school kids after school. You tutor for different times each week according to the distribution below. So sometimes you tutor 1 hour, that's about 30% of the time. 2 hours is 30% of the time. 3 hours is 20% of the time. And 4 hours is 20% of the time. What are the mean and standard deviations of the hours you work? So again, I have all of this data from this one and the next one in there for you. So you have your hours and the probability that you work. So columns A and B are for this. So I ran the stats on this, and x bar, our mean, is 2.3, and our standard deviation is 1.1. Now if we were to interpret this, we would say, on average, we would tutor 2.3 hours per week. On average, the amount of hours that we tutor per week varies by about 1.1 per week. What are the mean and the standard deviations of the money you earn, E? So let's set up an equation. E equals our hours times our money, which is $12 an hour, right there. So we're multiplying by a constant. Remember, multiplying by a constant changes both. So we're just going to multiply 2.3 and 1.1 times 12. So I did that on the calculator already. 27.6 and 13.2. So let's interpret real quick. On average, we'd make $27.6 per week. And on average, the amount of dollars per week we would make varies by about $13.2. Now suppose that you'd like to become more like Mr. Thompson. So you want to learn how to play the guitar, so you take lessons that cost $8 per session. With your busy schedule, you can't take lessons every day, so your lessons are different according to the distribution below. It's going to be per session, so it doesn't really matter. Sometimes you have 0 sessions per week, that's 40% of the time. Sometimes you have 1 session, 0.3, and 2 sessions, 0.3. What are the mean and standard deviations of the number of sessions that you take? So again, we could multiply 0 times 0.4 plus 1 times 0.3 plus 2 times 0.3, or we could just use our calculator because you have to find the standard deviation anyway, which is harder. So my guitar data is already in there, and I ran the one variable stats. So our x bar is 0.9 and our sigma is 0.83. So on average, we have less than 1 session, and that varies by about 0.83 sessions on average. What about the mean and the standard deviation of the money you spent? So this cost is 8 times the sessions. So we're just going to multiply everything by 8. So 7.2 and 6.64. Lastly, you are saving money each week to pay for a new car. Let V represent your savings. So V equals E minus C. What is the mean and standard deviation of V? So we're putting this distribution together with this distribution and we're subtracting. So the average of V is mu of E minus mu of C, right? We add or subtract these means. So the mean that we earn is 27.6 minus that 7.2 that we spend on guitar lessons for a grand total of 20.4. So that's our savings. We save about $20.4 per week. Remember, standard deviations do not add or subtract, variances do. So we're going to take this variance of our savings, so squared, equals our variance of our earning, so squared, plus our variance of our cost, right? Remember, it's always plus. Even though we're putting two distributions together, our standard deviation, our spread, is going to get wider because we're putting two distributions together. There's always going to be more error. So this equals 13.2 squared plus 6.64 squared. And I have that already for you. 218.33. Well, that seems really, really high. Well, it's high because that's the variance, not the standard deviation. So to get the standard deviation, all we need to do is take the square root of both sides. So I took my square root, and I got 14.776. Now, I could have just taken my square root here and just done everything all at once, that would have given me the same answer. I'll show you that in another example. When we combine normal random variables, we know the new distribution will be normal. If you take one distribution that's normal, put it together with another distribution that's normal, the result's going to be normal. We're not going to worry about anything outside of that realm. The weights of adult men are approximately normally distributed with a mean of 190 pounds and a standard deviation of 30 pounds. So let's call this the mean of the weight, and this is the standard deviation of the weight. And this is for the population. If you randomly select two men, what are the mean and standard deviations of the sum of their weights? So we're adding them. So the mean of the sum equals the mean of the first weight plus the mean of the second weight. So that's just 190 plus 190. So 380 pounds. Then we have our standard deviation of the sum. Well, remember, the standard deviations don't add, the variances add. So we're going to do 30 squared plus 30 squared, and then we'll take the square root of everything to get that standard deviation. So 30 squared and 30 squared, and the square root is 42.43. If you randomly select three men, what are the mean and standard deviations of the sum of their weights? Well, we just need a third one. So the sum of the three men is what I'm going to call it, S3. So I'm going to add one more male mean. So I'll get 470 pounds for the three. And then our standard deviation, 30 squared plus 30 squared plus 30 squared, all square rooted, is 51.96. And this is a great example of a great AP test question. An elevator in a small apartment building has a maximum weight capacity of 700 pounds. If three randomly selected adult men get on the elevator, what is the probability that they exceed the maximum capacity? Well, we want a distribution of the three men on an elevator. So we know the mean and we know the standard deviation. So the mean is 470. The standard deviation is 51.96. And we want to know the probability that the weight of the three men, so let's call that S3, is greater than 700 pounds. So let's assume that that's like here. I'll go through the button pushing for you. Menu, statistics, distributions, normal CDF, from 700 to infinity. Our mean was 470, and our standard deviation was 51.96. So very, very, very small probability that those three men are going to be over 700 pounds. And that makes sense. If you randomly select two men, what are the mean and standard deviations of the difference of their weights? Well, now we need to have the differences. So mu of the differences, we can say diff or just d, mu of one weight of a man minus another mu of another weight of a man. So this is 190 minus 190. So mu of the differences is 0. And then the standard deviation of the differences is going to be the same, right? It's that 30 squared plus 30 squared square rooted, okay? Because we're still adding even though we're looking at a difference because it's getting wider. We're introducing more error by putting these two distributions together. So that was 42.43. What is the probability that the difference of their weights is more than 40 pounds? So we need a distribution of differences. So mu of the differences is 0. Sigma of the differences is 42.43. And we want to know the probability that the differences in weights is greater than 40 pounds. So let's say 40 is about here. And we want to know this whole area. So I already have that right here for you. It's 0.1729.